And sometimes the on times are important, especially like on a maybe a crankshaft or aftermarket. I think I seen somebody do. They had an aftermarket part. I think it might be in the book also. They actually had an aftermarket part when the on time was off, causing the problem, causing the aftermarket part. And they found it by using the cursor measuring the on time. We had the guy. We had a guy in my last class before we went to the COVID-19 break. Was on a Volvo, and he had a lean code, right? Like the mass airflow sensor. So he put a new one in there. He spent maybe $400 on his mass airflow sensor. A new aftermarket part. 2 weeks on this, come to find out, that sucker was just out of calibration. They rolled the dice on it and went to the dealership and got another one and fixed it. And now if the aftermarket was a lot of money, you can imagine from the dealership how much it costs.
Oh, yeah.
I said, who paid for it? He said, we just ate it. You can't charge the customer twice. They ate it. They ate the difference.
Yeah, I guess those electronic parts, they can make them wrong.
Yeah, especially aftermarket. Anyway, I'm going with that story is, I said, did you ever put a lab scope on and try to measure it? They said, nah, we know how to do it. I would just love to know what the difference was from that aftermarket mass airflow. I think I have it in my classroom too. I think he gave it to me. I said, you said, and the new one from the dealership, you know what I mean?
Yeah.
What
you might find is that it's like a certain airflow rate.
Yeah.
You get your hertz is off.
Yeah, it had to be something.
Your frequency's off.
Yeah. It had to be something. I would love to know what it was. All right, so that's the time. So we almost done for the night. So again, here is the scales. I think this is actually a Vantage. I think this is actually the Snap-on. Okay, so anyway, every scope has a way to adjust it, either the voltage or time. They have a selection scale. Remember, you have to pick how the way I like to set it up. I like to set the voltage up first, representing that signal. If I have an O2 sensor, you know it's going from 100 to 1,000 millivolts, right? So I set my scope up to represent that. If I have a TPS, I'm going from 0.5 to up to 5 volts. I set my scope to represent that. And what I mean by that, if I can check a TPS on this screen. But if I have it on 20 volts, the height is going to look completely different. If I change it to 5 volts, or what can I go to? 6? Can I go on this? 5 volts. It's going to look, this a 5 volt signal versus a 10 volt signal is going to be more zoomed out to you. Does that make sense? If I have a TPS, I'm checking. It go from 0 to 5 volts. That's the voltage range. If I got on 10 volts, my screen from top to bottom is 10 volts. I'm still going to see that signal. But if I set it to 5 volts, I get a better representation of that signal. Because 5 volts represents that signal. Okay.
Basically like using a multimeter when you check a battery. If you go to a higher scale, you don't see the the voltage is different.
Yeah,
because to a lower scale.
Yeah.
Right. Yeah.
And time's the same way. I used to try to set the time up, get 2 or 3 repetitive signals on the screen. Right? And I just used to adjust the time in slowly. Then we're going to talk about trigger and slope later on to make it stay still for you. But I usually go with voltage and time so I can see it on the screen. Voltage first, then the time.
The only thing I don't see there on the voltage is how you set the 0 in the middle, and then you for like alternating voltage.
Oh yeah, for AC.
Yeah. So I guess you'd have to go. I mean, this is obviously direct current right here.
Yeah.
So you'd have to switch it to AC to get those kinds.
On this scope, maybe, but most other scopes you don't. You do it on DC, right? And you still see a picture. You just adjust it to it. You just
it has like a plus or minus.
yes, yeah, plus or minus, yeah.
Yeah.
Now on this one, I'm not sure.
That's all DC there.
Yeah. But you know what? Actually, like on the Pico scope, even though you use the AC, you still keep it on the DC setting. The only time you go to the AC setting when you want to couple the AC, when you want to couple, that means you're gonna get rid of the DC and just see all AC voltage.
Oh, okay.
But usually, 90% of the time, it stays on DC. And you'll go plus or minus, adjust for it. Now, next week when we come back, we're going to talk about amplitude, which is the height of a signal, frequency, how we turn it on per second, trigger, when it starts drawing a picture, slope, the direction of the signal, you want to start drawing the picture on the screen, the shape of the signal, AC, DC, all the different shapes that a digital signal can make. They all not a perfect square corner, believe it or not. Pulse width modulation, pattern relationship, cam crank, TBS, mass airflow, front and rear O2 sensors, the relationship between two sensors. On the test, they're mostly talking about cam and crank. We're going to go over that. And using the cursors.
Sorry, what did you say about the frequency on frequency?
How many times something turn on and off per second? How many times the components turn on and off per second?
Oh, okay, I see.
Let me I'll leave off with this. Like this one right here, current.
Yeah.
Right here, AC signal.
Yeah, it's like a speed sensor signal.
Yeah. It's a speed sensor. That's the most common one. It's actually a test question too. That's the most common one, the speed sensor. But look at this. Here's the zero line right here. Right?
Yeah.
The zero is right here for this signal. It's a positive and negative voltage. Right?
Yeah,
See
they got
zero,
that funny little,
positive, and negative.
that funny little thing in the middle there. I guess that's
Right here.
the computer uses that for some reason.
Yeah, this is the trigger right here.
Yeah.
That's the trigger. But you lose the cursors, you can see my voltage from high to low is my voltage high is 7 volts. Right? On a low end here it's about 3. They must have this hooked up to the battery. But again, it's an AC signal. This is a permanent magnet.
Yeah. Yeah, it's a very common sensor.
Yeah.
Yeah, they use digital speed sensors too for the wheel sensors, square waveforms.
Which car has that one?
I've watched some videos on them. They've got
Really?
yeah, they've got some wheel speed
is
sensors
it-
that are actually digital. They're
Is it in a differential or just actual wheel at the wheel?
no, they can use them at all.
Really?
Wheels.
I don't think I've seen that one.
And I saw a good scanner Danner video where all the dealer information was showing you how to test it. It was a 0 to 5 volt thing, but it didn't even work like that. It was a very low amperage type of input.
Low
that you
amperage or
discovered.
low amperage or low amplitude?
Amperage.
Amperage.
They were using an amperage input like an air fuel sensor. They were using an amperage input, but it was so tiny. He had to put it on the lowest scale, but you could see it. It was an AC. It was a signal like that, but it was a really low amperage signal.
Oh,
And
okay.
all the dealer information was wrong, and he just picked it apart. It's an amazing video. I'll find it again, and I'll tell you where it is. But
I would like to see that.
that will open your eyes up.
Yeah.
That video,
Yeah.
because he figured it. He did another one with the O2 sensor. Some of they don't work.
They don't work. Yeah.
That's good. He picked it apart and and he figured that it was some problem with, you know, how these a lot of these O2 heaters are pulse width modulated.
Yeah.
And then the other ones had full grounds.
Yeah.
And there's some kind of incompatibility there.
But
it was the replacement, but they just don't work.
Yeah, we had one like that at school. It was a Jeep. Yeah, the replacement was acting crazy. We had to get it from the dealership, and it worked. Right? I had to get it from. We had a cancers like that too. We put on the last school. He changed that cancer 6 times. Right? We got it from the dealership.
Parts don't work.
We got it from the dealership, and it fixed it. Even I was shocked. I thought it was a valve timing problem. Right? But it was actually the part we had to get from the dealership.
Yep. It's the design.
The design of it. Anyway, gentlemen, that would be it for the night. So, also, remember, I'm going to do. Don't forget to sign in for the night of Schoology. And between now and next week, I'm going to put some questions up on Schoology, right? And I want you to answer that we just went over through the book. And they might be on the test also, the final. That will not be on Lectitude. That would be on Schoology. Okay, that would be like somewhere. Let me go. Oops. Let me stop.